This session will discuss the setup of CCDAutoPilot. A key concept of setup is initialization. This is the process whereby CCDAutoPilot acquires information about your camera, your rotator, your guider, and their relationships so it can ensure accurate pointing anywhere in the sky and optimal guide vectors for superior guiding anywhere in the sky at any camera rotation and on either side of the meridian. We begin by filling the information on the equipment box on the right. We'll start by entering the focal length for the telescope, and as I enter the focal length and watch it go up and down, we can see the unbend image scale immediately underneath is recalculated on the fly. So the first thing we have to do is enter the focal length of our imaging telescope. Additionally, I define for G2V filter purposes what are the red, the green, and the blue filters that I'm going to be dealing with when I do color imaging. Since I've chosen to use off-axis guiding, the focal length for the guider is of course grayed out. I did have to enter the pixel size for the guider. For my guider, the A/D bits per pixel is 16, and I use 2x2 binning. For the mount, I have a German equatorial mount. It operates at a guide rate of 0.5 sidereal. I've allowed 3 seconds for it to settle. I don't want to track any lower than 5 degrees in the west, and I can come right up to zenith for the east and west altitude. I've selected precision slew to within 20 arc seconds. So now what I need to do is essentially find a guide star, calibrate my guider, and then calibrate the guider again under CCDAutoPilot control. Now the one feature we can do here too is, since I'm using a rotator, is we can test the rotator direction to make sure that the rotator in fact moves as it should for proper correction of position angles. So I'm going to begin by enabling the test rotator direction. Even though I'm going to ultimately use an off-axis guider, I'm going to select unguided so that I can get the rotator offset and the initial settings first. That will help me find a guide star later on. So let's begin by initializing. In the status bar at the lower right here, we see we're exposing the imager, which is basically taking in this case, a 5-second 3x3 bend image, downloading it, and then we'll plate solve it. It's now moving the rotator by basically 10 degrees different position. Take another image and basically plate solve it to see, did the position angle change in the direction it should for the rotator movement. If it didn't, it would note that and inform you of that at the end. So now it's moving back to 230.5 degrees on the rotator. It's going to take a third plate solve. And so it passed the rotator test. Initialization is complete, and we're asked if we want to save this to a system profile, which we do. So I'll just save it to one with today's date. Just my convention. It can be whatever you would like it to be. So at this point I have an unguided initialization. What this means is that I can position the field of view indicator or enter a target position angle and have CCDAutoPilot not only slew to the target in right ascension and declination, but also use the rotator for position angle. So now I'm going to set this up to be off-axis guided, which is what I'm using. Session page. We're now at the session page with the light frames tab selected. If I look at the Sky X, you'll note that I really don't have any guide stars available in this field of view. However, there's a nice bright one up there, which is perfect for this testing. So what I'm going to do is I'm going to select the field of view indicator and drag it a little bit, and then I'm going to rotate it so that that star is centered in my guider field of view indicator. Having done that, I'll now go back to Autopilot, and I'll say just get that target, and I'll just put in an arbitrary template. It doesn't matter. So now I have the right ascension, declination, and position angle of the center of the field of view indicator, and now I'm going to right click and say do a precision slew to that target. What that will do is move the rotator and slew the telescope, and we will have the guide star properly centered on the field of view indicator for the guider. You can see at the bottom that the telescope is slewing, and the rotator will move, and we'll just pause here and wait for that to get done. Now doing our first precision slew attempt. CCDAutoPilot will keep trying to get precisely aligned on the target to within 20 arc seconds or as close as it can get based on what we have specified on the mount settings on the setup page. You may have seen it flash briefly by that the try one slew error was 127 arc seconds. And now we're within 9.5 arc seconds, so we're very close. The next step is to manually calibrate the guider in the camera control program. In this case, I'm using CCDSoft. I've brought part of the window into the recording frame. So I'll now hit the calibrate button, and we will see the guide star, which is right here, move in X and Y as CCDSoft calibrates the guider. Now this is being done solely to give CCDAutoPilot some information about the relationship between the guider and the imager. So now we see we have a successful guider calibration with CCDSoft. We now return to CCDAutoPilot, back to the setup page. We're still pointed at our target where we want to be, and so now we're going to initialize again, this time with the off-axis guided method selected. Initialization will again repeat the rotator offset measurement. We know we don't have to check the rotator direction again, so we will save some time by not doing that, by unchecking this box. But now our initialization will consist of not only the rotator offset to position angle measurement, but also the necessary guide vector data that CCDAutoPilot needs to be able to use predictive guiding to set your guider optimally for any camera rotation on either side of the meridian anywhere in the sky. So let's begin initialization again. Once again, it begins by exposing the imager and doing a plate solve to determine the offset between the rotator position and the position angle of the star field. Now it's repeating the exact guider calibration that we did before manually. The reason to do it manually, of course, is to make sure that you get a good guide calibration. The guide star stays on the guide chip and so on. CCDSoft reported our drive calibration was successful, and CCDAutoPilot is saying initialization is now complete. We'll save these settings again, overwriting the prior system profile because that was an interim setup. So at this point, we're all initialized and ready to go forward with any kind of imaging anywhere we want, confident that the resultant guide vectors will be optimally calculated and fed into the camera control program.